Good morning, dear students. In last lecture, we have explained Daniell cell, voltaic cell, or galvanic cell. Now we will understand the cell representation. That how can we explain the representation of cell or half cell? Today's our topic purely depends on this content. That we have to explain the representation of half cell and standard cell, and we will define cell potential. But what can we do, or how can we explain this point? Just we will focus on board. Just see here, this is the question is here, half cell and its representation. First of all, what is the definition of half cell? In very simple words, just see here, we have a electrolyte solution ZnSO4, and now I will add zinc strip in it. So this is half cell, that electrolyte, strip and a beaker. So half cell, the definition of half cell is here, it is a structure that contains a conductive electrodes, that structures contain a conductive electrode and surrounding conductive electrolytes separated by a naturally occurring layer. This is half cell. So half cell is a structure that contains a conductive electrode and surrounding conductive electrolyte separated by a naturally occurring layer. It is known as half cell. So the question arises in our mind that how can we explain the representation of half cell? Just see, in half cell, two important parameters are here. Number one, it is electrolyte, and number two, it is active ion. Active ion means conductive electrolytes. Okay, so for the representation of half cell, we have to understand that there are two important parameters in half cell. Number one, it is electrode, and number two, it is active ion. So we have to put a vertical line between electrode and its active ion. So the representation of half cell is here, that we have to put vertical line between electrode and its ion, so zinc and zinc 2 plus. So the first important point is here, that how can we explain the representation of half cell? So the answer is here, we have to put a vertical line between electrode and active ion. समझ सकते हैं आप, ये मुझे रिप्रेजेंटेशन करना है तो मुझे यहाँ पर वर्टिकल लाइन करनी पड़ेगी इलेक्ट्रोड और आयन के बीच में. देखिए यहाँ पर इलेक्ट्रोड कौन सा है, जिंक का, और यहाँ पर आयन कौन सा है, ZnSO4. बट ZnSO4 में जिंक किस फॉर्म में प्रेजेंट है, तो इट इज प्रेजेंट एज अ Zn2+. So we have to put a vertical line between electrode and its active ion. Electrode having solid in physical state and Zn2 plus 1 molar. So the second important point, that we have to calculate the concentration of active ion. The formula is here, it is content, the method is here, it is molarity. So we have to put molarity beside the active ion. सो एक्टिव आयन के पास में हमें ब्रैकेट करके यहाँ पर मोलारिटी दिखानी पड़ेगी. यही इसका इम्पोर्टेंट पॉइंट है अगर हम रिप्रेजेंटेशन करते हैं तो. और जो भी मेटल हमारे पास है उसके बाजू में भी उसकी फिजिकल स्टेट हमें करनी पड़ती है. सॉलिड, लिक्विड, गैस जो भी है वो फिजिकल स्टेट यहाँ पर हम लिखेंगे. सो Zn सॉलिड टू Zn2 प्लस. सो दिस इज द हाफ सेल Zn, वर्टिकल लाइन Zn2 प्लस. सो दिस इज द रिप्रेजेंटेशन ऑफ हाफ सेल. Now the next question is here, representation of cell. Representation of cell. Just see, how can we represent a cell when two half cells connect with each other. At that time cell will prepare. Very simple, Daniell cell, we put a word cell behind Daniell because there are two half cells, one number ZnSO4 and the other beaker we have taken CuSO4. So when two half cell connect with each other, cell will create. But how can we represent cell? The formula is here, just see. I am taking here directly representation, Zn2 plus 1 molar Cu2 plus 1 molar Cu. Just see which are the important parameters for the representation of cell. Just see, if we are using salt bridge, then we will put this sign, two vertical lines. If we are using salt bridge, then we will take two vertical lines. This is a pure and proper symbol of salt bridge. So if we are using salt bridge, we will put two vertical line, but if we are not using salt bridge, then we will put only one vertical line. So with salt bridge, two lines, and without salt bridge, one lines. Okay, this is the first important point. Then second point, this is the second important point. Left hand side, on the basis of simple presentation, we have to put anode on the left side of salt bridge and right side means cathode. ये हमें याद रखना है कि जो लेफ्ट साइड वाला होगा वो रिप्रेजेंटेशन के तौर पर एनोड रहेगा, और जो राइट साइड वाला होगा वो रिप्रेजेंटेशन के तौर पर कैथोड रहने वाला है. सो लेफ्ट साइड का एनोड और राइट साइड का हम रखेंगे कैथोड. सो इट इज एन अगेन इंपॉर्टेंट, बट याद रखिएगा स्टूडेंट्स, लेफ्ट हैंड साइड का एनोड रहेगा, राइट हैंड साइड का कैथोड रहेगा. वैसे भी आपने डेनियल सेल देखा होगा, लेफ्ट साइड में ये ZnSO4 था, वही एनोड के तौर पर एक्ट हो रहा था, और राइट साइड में CuSO4 था, वही कैथोड के तौर पर एक्ट रह रहा था. So it is an important point. On the left hand side anode will present, and on the right hand side cathode will present. So LHS anode and RHS cathode. This is the second important parameter for the representation of cell. The third one you represent here, that concentration is in molarity unit. We have to put concentration in molarity unit besides the ion. And we have to put bracket among this. So besides the ion, Zn2 plus and molarity in bracket. So we have to put concentration in molarity unit beside the ion. If we are using gas electrode, just see, if we are using gas electrode, then this is inert electrode, platinum, then again vertical line, gas that we will pass from this. If we are passing hydrogen, then hydrogen gas 1 bar, again line H plus concentration. So if we are using gas electrode, then we will represent the cell as on this way, Pt H2 gas and H plus in 1 molar. So it is very simple concept, representation of cell. Just we have to check the three important points. First one, that we have to put vertical line between the electrode and its ion. The second, if we are using salt bridge, then we will put up two vertical lines, and if we are not using salt bridge, then one vertical line will present there. Say third important one, left hand side we will put anode, on the right hand side we will put cathode. Again this is very simple. And if we are using gaseous electrode, then we have to use bar in a gaseous form, gas and 1 bar pressure besides the H2, and concentration H plus 1 molar. So this is the representation of cell. Again we will focus on the board. I will take an image about this one, then we will go through in our next important question, which is known as cell potential. Just see, because if we wanted to check that chemical energy convert into electrical energy, that means we have to understand that how much electrical energy will produce from the cell, then this energy will measured by potentiometer. Okay, so the next important question is the definition of cell potential. And what is cell potential? Now we will see. Cell potential. Cell potential. What is cell potential? Just see. The symbol of cell potential is here. Each standard cell is a symbol of cell potential. Here dot means the cell is in a standard condition, in which condition is applied 25 degrees Celsius temperature, 1 bar pressure and 1 molar concentration. Then what is cell potential? Let's see. Pressure. Cell potential is a one type of pressure. but with the help of this pressure, chemical energy convert into electrical energy. Just see a pressure in electrochemical cell. जब हमारे पास कोई इलेक्ट्रोकेमिकल सेल है, देखिए इलेक्ट्रोकेमिकल सेल में फ्लो ऑफ इलेक्ट्रॉन किस तरफ जाता है. सो फ्लो ऑफ इलेक्ट्रॉन विल गो थ्रू फ्रॉम एनोड टू कैथोड इन इलेक्ट्रोकेमिकल सेल. एट द टाइम विद द हेल्प ऑफ दिस प्रेशर the flow will create. This pressure is known as cell potential. Just see, that means cell potential is a one type of pressure. With the help of this pressure, flow of electron will go from anode to cathode in electrochemical cell. This type of pressure is known as cell potential, and the symbol of cell potential is E standard cell. So this is our cell potential. And how can we find cell potential? So if we want to find exact value of cell potential, then we will use potentiometer. So potentiometer is a name of instrument that we will find the exact value of potential. Potential का अगर हम सिमिलर वर्ड अगर सोचते हैं तो वोल्टेज भी हम बोल सकते हैं, बट वोल्टेज बड़े इंस्ट्रूमेंट्स के लिए होता है. स्मॉल स्केल पर पोटेंशियल वर्ड का यूज किया जाता है. और एग्जैक्ट इम्प्रॉपर वोल्ट मीटर विल यूज. इस समय एग्जैक्ट वैल्यू नहीं मिल पाती है, पर नज़दीक की वैल्यू मिल जाती है. बट एग्जैक्ट वैल्यू के लिए हमें पोटेंशियोमीटर का यूज करना पड़ता है. अगर हम फॉर्मूला की बात करें तो ये हमारे पास फॉर्मूला है, E standard reduction of cathode minus E standard reduction of anode. E standard cell is equal to reduction of cathode minus reduction of anode. स्टूडेंट्स ये फॉर्मूला खास याद रखिए, क्योंकि इसी के तौर पर हम ये आगे बढ़ने जा रहे हैं, क्योंकि हमें जो भी न्यूमेरिकल सॉल्व करना है वो इसी तरीके से करना है. दूसरी फॉर्मूला भी ऐसे ले सकते हैं, E standard cell is equal to E standard oxidation of anode माइनस ऑक्सीडेशन ऑफ कैथोड. अगर हम रिडक्शन का इस्तेमाल करते हैं तो समझ लीजिए ये RHS माइनस LHS हो गया, क्योंकि राइट हैंड साइड वाला कैथोड होता है और लेफ्ट हैंड साइड वाला एनोड होता है अगर रिडक्शन की फॉर्मूला में. और अगर ऑक्सीडेशन की फॉर्मूला में इस्तेमाल करते हैं तो LHS माइनस RHS होता है. पर वो कौन सी फॉर्मूला हम यूज़ करेंगे वो हम बाद में देखते हैं. पर यहाँ पर आप मार्किंग कीजिए, दोनों कैथोड अगर हम ले लेते हैं तो ये ऐसा इंडिकेट करता है दैट ई स्टैंडर्ड रिडक्शन इज इक्वल टू ई स्टैंडर्ड ऑक्सीडेशन. रिडक्शन और ऑक्सीडेशन दोनों की वैल्यू सेम ही होती है, बट मैग्नीट्यूड इज डिफरेंट. ई स्टैंडर्ड रिडक्शन इज इक्वल टू माइनस ई स्टैंडर्ड ऑक्सीडेशन. दिस इज द फॉर्मूला, जस्ट वी हैव टू प्रिपेयर दिस पॉइंट दैट ई स्टैंडर्ड रिडक्शन is equal to minus E standard of oxidation. So this is the relation then we will prove from this theory. So remind this important point that E standard cell is equal to reduction of cathode minus reduction of anode, or anode minus cathode if we are using oxidation formula. But what is cell potential? So the pressure which will create the flow of electron from anode to cathode in electrochemical cell, it is cell potential. If we want to find the exact value of potential, then we will use potentiometer, and from nearer value we have to use the voltmeter for this one, and this is the formula for the calculation of cell potential. So this is the important points of cell potential. But the question arises in our mind that how can we find the cell potential with the help of potentiometer. That then for the answer of this question we will understand first of all standard hydrogen cell. After the explanation of standard hydrogen cell, then we will develop a new technique for the calculation of cell potential. So this is again an important point. आप समझ सकते हैं कि अगर सेल पोटेंशियल फाइंड करना है तो हम फॉर्मूला हमारे पास है और उसका एक्सपेरिमेंट भी है. मैं आपको एक्सपेरिमेंट के तौर पर समझाऊंगा कि किस तरीके से सेल पोटेंशियल फाइंड हो सकता है. So this is the electrode potential of half cell, electrode potential of cell. हाफ सेल का इलेक्ट्रोड पोटेंशियल फाइंड करना है, इजी नहीं होता, पर वो किस तरीके से हम फाइंड करेंगे वो मैं आप सबको बताऊंगा. थैंक्स. बात हमारी यहाँ पर ख़त्म हो रही है. थैंक्स.